Good morning. This is Hassler here. I'm going to talk about um, some practice problems before working on 7.6a. And so in the next unit that we talk about, we're going to be looking at something called factoring. We've been multiplying two groups together. In this case, we're going to be working backwards and taking the answer and breaking it back down into those two groups or factors. And before we do that, we want to talk first about what is a GCF. And so my next little slide here should say, what does GCF stand for and what does it mean? So GCF stands for greatest common factor. And this is something that I know you've talked about in your past math life, factor. And I think what we have to talk about first is what is a factor? And so a factor is a number that gets multiplied by another number. And so the result of that would be the answer to that multiplication, which is what we call a product. And so these two are called factors, the two items that get multiplied together, and this is called the product. And so what I'm looking for in a GCF is I'm looking for the greatest factor, the greatest number we multiply that two terms have in common. So for example, if I had 10 and 12, I would want to find all the factors of 10. 1 times 10, 2 times 5. I want to find all the factors of 12. 1 times 12, 2 times 6, 3 times 4. And then I want to look to see which ones they have in common. Well, they both have a factor of 1 and they both have a factor of 2. And of those, the biggest factor they have in common is 2. So 2 in this case would be the GCF between 10 and 12. Okay, so factors are numbers that are multiplied together to get a product, the answer to that multiplication. Our job is going to be, if I'm given 2 or more terms, to find the greatest number that can be multiplied for any of those terms. Okay, the greatest factor. All right, so what we're going to do is we're going to go through a couple of examples together. And this first example is 8 and 24. I want to find the GCF of 8 and 24. And so I want to list some factors of 8. 1 times 8, 2 times 4. That's it. And I want to list factors of 24. So what I like to do to keep track of the factors I already have and whether or not I'm done finding factors is I always like to start with the factor of 1. So 1 times 24. And then I like to do 2. Well, yeah, 2 times 12. And then I like to try 3. Yeah, 3 works. 3 times 8. How about 4? Yeah, 4 times 6. How about 5? No, 24 divided by 5 is something like 4.8. So that's not going to do it for us. How about 6? Oh, yeah, 6 works. But I already used 6 here, which means that I've covered all of the factors. So if you start in order from 1 and you move through 1, 2, 3, 4, and then you find you come to a factor that has already been written in your list, then you're done finding factors. All right, so the biggest factor that these two have in common is 8. So my GCF here is 8. All right, 9 and 15. Again, I've got 1 times 9, 3 times 3. I have 1 times 15, 3 times 5. All right, the biggest number that 9 and 15 have in common is 3. All right, so let's move up a level into algebra, and let's talk about what happens here. I have negatives this time. So really, I could write this as negative 1 times 3 or 1 times negative 3. And for 21, I could write negative 1 times 21, or it could be 1 times negative 21. I could write negative 3 times 7, or 3 times negative 7. So the fact that I have these negatives to account for means that when I have my factors, one factor is positive and one is negative. Now, the other thing we're going to talk about as we get further into these next couple of days is that anytime I have terms added or subtracted, and that first term, that leading term is negative, then I want the negative version of that GCF. And so for this case, we're going to say that my GCF is negative 3. So sometimes that negative will be a part of the GCF. All right, let's take a look at what's happening over here. I have some variables in play. So let's just worry about the number to start. For 6, I've got 1 times 6 and 2 times 3. But the x squared means that there are 2 x's that are also being multiplied together. So I'm going to write x times x. And for 33, I've got 1 times 33 and 3 times 11. But I have only one x. I'm going to go ahead and say, okay, and there's one x there. And so what happens is I'm going to circle the largest number they have in common. The largest number they have in common is 3. And I'm going to circle how many x's they have in common. The most x's they have in common is 1. They have one x in common. So 3x would be my GCF. So sometimes our GCF could be negative, and sometimes our GCF could have variables. All right. So let's bring this all together. And I'm going to come back here to terms we've actually already dealt with. We've dealt with the 8 and the 24. But these directions say rewrite the expression as a pair of factors using that GCF. So this time we notice that I have this plus sign. It's not just 8 and 24, it's 8x plus 24. And so I want to take this expression and I want to rewrite this as 2 items that are getting multiplied together. That would be equal to that 8x plus 24. Okay, and I want to use the GCF to do that. So if you recall, we said the GCF between 8 and 24 was 8. And so I'm going to say 8 times, I'm going to use parentheses for my times. And in these parentheses, I need to write what it takes to go from 8 to 8x and to go from 8 to 24. So 8 times x gives me 8x plus 8 times 3 gives me 24. And so what we're doing is we're taking this expression, 8x plus 24, and we are breaking it apart into 2 factors, 2 things that could get multiplied together. Just like we took 8 and we broke that apart into 2 numbers that could get multiplied together. Only this time we're doing it with an expression, this plus or minus. All right, same idea over here. If you recall, the GCF between 9 and 15 was 3. And so what I'm going to do is I'm going to rewrite this as 3 times whatever it takes for me to get 9x minus 15 when I multiply these 2 factors together. So 3 times 3x would give me 9x, and 3 times negative 5 would give me that negative 15. And so these are my factors. Okay, these are 2 items that get multiplied together. Let's come back here and look at this negative situation that I was describing earlier. If you recall, we had said that the GCF was negative 3. And I notice here that my first term is negative, which is why I'm including the negative in my GCF. So again, I want to break this down as a pair of factors using that GCF. So negative 3 times whatever it takes to get that negative 3x minus 21. Now, for some people, it's easy to see what has to get multiplied, and for others, it isn't. What I'm actually doing is I'm dividing out that GCF from each of these terms. Negative 3 divided by negative 3 leaves me with an x, and negative 21 divided by negative 3 leaves me with a plus 7. Now, I can always go and check this, right? The 2 numbers there, the 2 terms that I multiply together, these factors, should match what I was given. So negative 3 times x is negative 3x, and negative 3 times 7 is negative 21. And so these would be my factors. Okay, that's our goal. Our goal today is to create 2 items that are being multiplied together. If you recall, the GCF for this was 3x. Both terms had at least one x. And so again, I'm going to write this as 3x times something else. And my goal is to get 6x squared plus 33x. Now, I said that you can always divide each term by this GCF if it's hard for you to see what the result would be in my parentheses. All right, so 6 divided by 3 is 2. And if I divide one of these x's out, I still have an x left over. 33 divided by 3 is 11. And if I divide these x's out, there are no x's left over. And then I'm going to do a check. 3x times 2x is 6. X times x is x squared. And 3x times 11 is 33x. And so this works out. And so that is going to be our goal for this particular lesson, is that I can find a GCF and then use that GCF to rewrite the expression as 2 items being multiplied. I just want to come back down and talk about something like this. So it says rewrite the expression as a pair of factors. Great. Okay, so first thing I have to do is find the GCF. And so the GCF, well, let's see, we've got 1 and 5 and XX, and we've got 1 and 20, 2 and 10, 4 and 5, and there are no x's there. So the only thing that is a GCF here would be the number 5. There are no x's in common. Okay, so I'm going to say 5 times, well, if I divide each of these by 5, I'm left with x squared minus 4. And I can always do a check, right? So 5 times x squared is 5x squared minus 20. This checks out. And so this would be my answer. These factors would be my answer. All right, let's talk about this over here, because now I see 3 terms and that first term is negative. So now I need to come up with a GCF here. And because that first term is negative, my GCF is going to be negative. Now, looking at 3, my only factors of 3 are -1 and 3 or 1 and -3, which means the factors in 18 and 27, which are going to be bigger than 3, don't really matter other than wondering if they have a factor of 3, right? Like if I could write all the factors 1 times 18, well, 18 can't be a GCF because my first term of 3 isn't even big enough to have a factor of 18. 2 and 9, well, 2 is not part of a factor of 3, and 9 can't be. It's bigger than 3. And then 3 and 6. Yeah, so the 3 could work here. And is 27 have a factor of 3? Yeah. So if I find the factors of that smallest term, I'm just checking to see if the other terms also have that factor. And again, because that first term is negative, I want my GCF to be negative. Okay, so -3 times, I'm going to make my parentheses bigger because I have 3 terms here now, all right? And I'm going to erase what we have here so I can do my division. Okay. So I'm going to divide by -3. Notice x is not part of my GCF because there's no x on the 27. Okay, so there's no x in the GCF because that third term does not have a variable. All right, so -3 divided by -3 leaves me with a positive x squared. -18 divided by -3 is a -6x. And if I divide this by -3, I get a positive 9. And again, you can always check to see if your answer matches the original. Especially with these negatives, you have to make sure that you have the right signs. And that works out. So your final answer are these factors, okay? So your job is to go work on the 7.6a worksheet on finding GCFs and rewriting expressions so that you have factors using that GCF. If you have any questions, let me know.